Welcome back to the course on machine learning using Python programming. So, in this lecture we will see hierarchical clustering. So, this is another technique of clustering. In hierarchical clustering, since this is another method of clustering, so definitely the results will be clusters, and it has been seen that results of hierarchical clustering are sometimes very similar to the results of k-means clustering, and there are two types of hierarchical clustering. First is agglomerative hierarchical clustering and another is divisive hierarchical clustering. So, let us start with agglomerative hierarchical clustering. So, these are the steps for agglomerative hierarchical clustering. In this case, first of all, each data point is treated as a single cluster, and that is why if there are n data points in the data set, we can, in the first step we will assume that there are n clusters and each cluster is corresponding to one data point. Then in step 2 we will take two closest data points and we will join them together to form single cluster. So, after doing this step we will have only n minus 1 clusters, because two most closest data points we merged together, and that is why one cluster is reduced. So, earlier we were having n clusters, now we will have only n minus 1 clusters. Then in the next step we will again take two closest clusters and we will merge these two clusters, and in that case we will have finally n minus 2 clusters, and we will repeat these steps several times until we are getting the required number of clusters. So, this is the way we generate clusters in agglomerative hierarchical clustering. So, let us see one example here. Suppose these are the data points. These are the data points in the data set. So, initially we will treat each data point as different clusters, then we will find out two closest data points. So, let us assume these two data points are closest, and that is why we will merge these two data points in a single cluster. So, earlier we were having 6 clusters, now we are having 5 clusters, because these two closest data points are merged together. Then in the next step we will again merge the next two closest data points. After that we will again find out the two closest clusters. So, here we are having 5 clusters, we will find out two clusters that are closest to each other, and suppose these are the two clusters that are closest. So, again we will merge these two clusters, and in this way we will now have 1, 2, 3 and 4 clusters. Then we will do the same thing again, we will find which two clusters are closest to each other out of these 4 clusters, and suppose these two clusters are closest to each other. So, we will merge these two again, and in this way we got 3 clusters. If we want to get 2 clusters, so we will take one more step and again we will find out of these 3 clusters which are the two most closest clusters, and suppose these 2 clusters are most closest. So, we will merge these two also, and finally if we want only one cluster, so basically we can say that this is the final one cluster. So, this is the process of agglomerative hierarchical clustering. Now, there are some questions that can occur in our mind. that first of all, initially all data points we are treating as different clusters. So, how we will find out the two most closest data points? So, it means we should have some distance metric, we should use some distance metric, and we can use any distance metric like Euclidean distance or any other distance metric we can use here, and in this way we will find out the two most closest data point and we will merge them to find one cluster. Then when we formed some clusters in which there are more than one data points, in that case again in next steps we are finding two most closest clusters. So, how we will get the distance between two clusters so that we can find two most closest clusters. So, there are different ways that we use generally to find distance between two clusters. So, one of the way is single linkage, then complete linkage, average linkage, centroid linkage, and Watt's method. So, these are different ways. Let us see one by one. In case of single linkage, what we do? We say distance between two closest point we treat as the distance between two clusters. So, it means we can say that distance between two clusters like C1 and C2 is minimum of distance of Pi and Pj, where Pi is belonging to cluster C1 and Pj is belonging to cluster C2. So, we are taking distance of those 2 points, that is minimum, and that is why this is distance between two closest point. So, how we will do this? Definitely we will need to calculate distance between all pair of points in two clusters, and then we will select the minimum distance between any two clusters, any 2 points in these two clusters, and that distance is called as single linkage distance. So, in this case, if we are calculating distance between two clusters using single linkage distance, in that case it tends to produce elongated chain like clusters, because we are only seeing the distance between two closest point, and rest of the points may be farther from these 2 points, and that is why you will get some elongated or chain like clusters, and it can be sensitive to noise and outliers also in the data, because we are only considering the points that are closest to each other. Then there is another way, that is complete linkage distance. This can also be used to find distance between two clusters. In this case, the distance between two farthest point of these two clusters are taken as that distance, farthest point distance is taken as the distance between these two clusters. So, that is written here, distance of cluster number 1, cluster number 2 is equal to maximum of distance Pi Pj. So, where Pi is belonging to C1 and Pj is belonging to C2. So, to calculate this, we will need to find distance between all pair of points in two clusters, and then we will take that two pair for which distance is maximum, and that distance we will take as the distance between two clusters. So, in this way we are calculating, it is called as complete linkage distance, and it tends to produce compact spherical clusters, because we are considering distance of two farthest points. So, definitely your cluster will be compact and spherical, and in that case it is less sensitive to noise and outliers also in compared to single linkage distance. Then the third way is average linkage, or it is also called as group linkage. So, we can find distance of two clusters using average linkage method also. So, in case of average linkage method, we calculate distance of all pair of points of these two clusters, and then we take average of these distances. That average distance is called as the distance between two clusters. So, you see, if cluster number C1, cluster number C2, we need to find distance between these two clusters. So, we will find out distance of Pi and Pj, where Pi is belonging to C1, Pj is belonging to C2. So, this will do for all Pi's and all Pj's. So, after that we will take sum of these and we will divide it by number of elements in C1 into number of elements in C2. So, in this way we will get average distance between all pair of points of these two clusters. So, this is called as average linkage. So, in this case, through this we are defining distance between two clusters. Then the next method is centroid linkage distance. In case of centroid linkage distance between two clusters, how we are treating? We will first off find centroids of these two clusters, and then we will calculate distance between these two centroids. So, that distance will be called as the distance between two clusters. So, centroid, definitely we can find centroid of a cluster as by taking mean of all the points in that cluster, or there may be, we need to find some way to find out centroid of the cluster. So, here if two clusters A and B are there and their centroids CA and CB is there. So, distance between two clusters A and B is defined as distance between these two centroids, centroid of A and centroid of B, and this notation is denoting the Euclidean distance between two centroids. So, any other distance we can also take, but we will need to find distance between two centroids, and then it is called as centroid linkage distance. Then we can say that if we will take centroid linkage distance as a distance between two clusters, then it will produce well separated clusters that are roughly equally sized and shaped. So, this we can treat as, we can say that this may be the best way for calculating distance between two clusters, and generally our goal is to minimize average distance between points in a cluster. So, but it can be sensitive to outliers, and it may not work well when the clusters have different densities or sizes. So, but centroid linkage distance is one of the way that we can use for finding distance between two clusters. Then the next method is Watt's method. So, what is the Watt's method? This method is it is basically when we are merging two, suppose in case of agglomerative clustering we are merging two clusters, and in the next step we are reducing the number of clusters like this. So, we can find whether the merging these two clusters in a single cluster is good or not. So, or we should merge any two other clusters. So, Watt's method can be used here. So, in this case it aims to minimize increase in variance. So, that increase in variance is defined as the sum of squared errors when merging two clusters. So, what was the for two, if there are two clusters, cluster A and cluster B. So, what was the variance of cluster A? What was the variance of cluster B? And when we merged these two clusters, then what is the variance? And then we can find out what is the increase in variance when we merged clusters A and B together. So, that will be variance of A union B minus variance of A minus variance of B, and this delta V is the variance in increase in variance. So, we can say that we will merge those two clusters for which delta V or variance increase in variance is minimum. So, in this way we can find which two clusters we should merge at a particular step of agglomerative clustering. So, we can say that we need to find all possible pair of clusters that can be merged, and then we calculate for those possible pair of clusters we will calculate increase in variance, and we will merge those two pairs for which increase in variance is the minimum, and this process will continue until we find the required number of clusters. So, this was the agglomerative hierarchical clustering, and now the question is how we will know what is the right number of clusters, and since we are merging in each and every step we are merging two closest clusters. So, when we should stop and when we will say that we got the required number of clusters or we got the correct number of clusters. So, we can say that the advantage or purpose of hierarchical clustering is that we are maintaining record of how these clusters are made. We know which two clusters were joined, were merged at the first step, then which two clusters are merged in the second step. So, in this way we finally got the final clusters. So, this information of merging clusters in different steps can be recorded in a data structure that is called as dendrogram. So, this dendrogram is a tree like diagram, and using this dendrogram we can tell at which step which two closest clusters were joined together. And so, these dendrograms are also used to find the optimal number of clusters. So, let us see how we will find the optimal number of clusters using dendrogram. So, suppose here we will see one example in which these 6 data points are there in the data set, and then using agglomerative clustering we are joining or we are merging clusters to closest clusters step by step, and finally we will get only single cluster. So, here we can see that point number data point P2 and P3, these are the closest point, because here this is the points in the data set and this is showing distance between two clusters. We have seen different ways of finding distance between two clusters, that is single linkage or centroid linkage and so on. So, we can find any way to calculate distance between two clusters, and here we can see that this is the smallest distance, and it means first of all these two clusters were added, were merged together to form a single cluster. Then we can say that this is the next highest distance. So, we can say that after that the closest two clusters were these, and that is why these are merged together, and then this is the next highest distance. So, this cluster and this cluster were merged together, and finally these two clusters were merged, and at last these two clusters are merged. So, in this cluster we are having 3 points P1, P2 and P3. In this cluster also we are having P4, P5 and P6. So, now here we can see this is called as the dendrogram. So, in this dendrogram we are having the record how the clusters are formed step by step. This diagram and this content has been taken from machine learning A to Z Udemy course. So, this is the way we record the formation of clusters in dendrogram. Now, this is another dendrogram. Now, we can find out optimal number of clusters using dendrogram. What is the idea? Idea is that we will take the longest distance between two clusters that were added. So, here the distance between these two clusters was this, then distance between these two clusters is this. In the same way, these are representing distance between two clusters, and this distance is representing distance between these two clusters. So, this is the longest distance. So, what we can do, we can set any threshold. Suppose that threshold is this. So, we will say that since this distance is greater than this threshold, and that is why we will not merge these two clusters, means cluster number 1 in which we are having P1, P2, P3, and cluster number 2 where we are having P4, P5, P6 data points. So, these two clusters we will not merge because distance between these two clusters is greater than the threshold. So, your threshold can be here also. In that case, we will not merge even these two clusters or these two clusters. So, in this way your dendrogram can be used to find optimal number of clusters. Here if we set this as a threshold, so in that case we will get only this one cluster, that is having P2, P3, and this is cluster that is having only P1, and this is another cluster, so P4, and this is a cluster in which P5 and P6 are merged. So, these are the 4 clusters that are formed if this is the threshold in dendrogram. So, we have seen how dendrogram can be used to find optimal number of clusters. Now, there are other methods also. In the previous lectures, sometimes we have seen we can use elbow method also to find the optimal number of clusters. Then there is Shillhut analysis. Using Shillhut analysis, we can again find the number of clusters, or it can be used for evaluating your clustering techniques or clustering results also. The technique is based on the concept of Shillhut coefficients. So, this Shillhut coefficient measures how well a data point fits into its assigned cluster compared to other clusters. So, it means we will calculate Shillhut coefficient for each and every data point, and for that data point corresponding Shillhut coefficient will give you the measure of how well this data point fits to its assigned cluster compared to other clusters. So, how we will do this? Shillhut coefficient for a data point is calculated in these 3 steps. In the first step, we will calculate average distance between that data point and all other data points in the same cluster. So, suppose we are taking any one data point that is in a ith cluster. Suppose that is in some cluster ith cluster, suppose. So, we will calculate distance of that data point with all the data points in the same ith cluster, and suppose that distance we are denoting as ai. So, then we will calculate average distance between data point and all other data points in the nearest neighboring cluster. So, we will need to find out the nearest neighboring cluster of this cluster in which that data point is belonging, and then we will calculate distance of this data point with all the data points that are in the nearest neighboring cluster, and we are denoting those distances as bi. So, then Shillhut coefficient will be calculated as bi minus ai upon maximum of ai bi. So, here we can say that if bi is greater than ai, it means the distance between this data point is, or it is more with the data points in other cluster, and this is small, means distance between this data point and other data points that are in the same cluster is less, and that is why this bi minus ai is some value or it is positive. So, we can say that Shillhut coefficient ranges from -1 to 1. If it is 1, it is well matched to the own cluster and poorly matched to the neighboring cluster, because this bi in this case is greater than ai. So, if B I is greater than A I, it means it is positive, and in that case B I is greater than A I means distance of that data point with all other data points of the same cluster is less, and distance of this data point with all other points in the neighboring cluster is large, and that we want. And so, we can say that if the coefficient Shillert coefficient value is close to 1, then it is good, or we can say that your formed clusters are good clusters, correct clusters, while if this coefficient value is close to -1, it indicates just opposite. It means in that case your B I is less than A I, because in that case it will be negative, and if it is -1, it means this distance between the data point with all the data points of the neighboring cluster is less than distance between this data point and all other data points with the in the same cluster. So, in that case this point should not belong to the assigned cluster, it should belong to the neighboring cluster. So, if this Shillert coefficient suggests that the value is -1, so it suggests that this data point is not well matched to its own cluster, it is well matched with the neighboring cluster. And a coefficient close to the 0, if this coefficient value is 0, in that case we can say that B I is equal to A I. So, we can say that your data point is at the boundary of these two clusters. So, here it is difficult to say to which particular cluster we should assign it, because it is at the boundary of these two clusters. So, using this Shillert coefficients, we can find out what is the quality of clusters that you are getting as an output, or this can be used when suppose we are using agglomerative clustering algorithm for finding different clusters. In that case also, if we are whatever Shillert coefficient we are having for different data points at a particular step, in the next step when we are merging two clusters, then again we will calculate Shillert coefficients for all the data points, and then if that Shillert coefficient value is more close to -1, it means we should stop, we should not merge these two clusters, because here after merging your Shillert coefficient value is not good, it was it may be good in the previous step, so we should stop there. So, finding optimal number of clusters using Shillert analysis. So, here what we can do, we will perform hierarchical clustering on the data set for different values of k, and then for each value of k we will calculate average Shillert coefficient across all data points in the clustering result, and then we will plot the average Shillert coefficient as the function of k. So, on the x axis you will have different number of clusters, and on the y axis you will have Shillert coefficients, average say a Shillert coefficient for all the data points corresponding to these number of clusters, and then we will find the optimal number of clusters will be the value of k for which average Shillert coefficient value is maximum. So, in this way we can use Shillert coefficient or Shillert analysis for finding optimal number of clusters. Now, the second way of hierarchical clustering is divisive clustering. So, in this clustering we can say it is a top down clustering, while agglomerative clustering was the bottom up approach, because there we were treating all the individual data points, individual clusters, then we were merging closest clusters to form next set of clusters. So, that was the bottom up approach, while in this case initially we are treating whole data set, all the points in a single cluster, then we will divide it in two clusters, then again we will divide one of these two clusters in two clusters, and so on. So, this is called as the top down approach, and here we are using divisive method for finding the clusters. So, initially all the points in the data points belong to a single cluster, then we will partition the cluster into two least similar clusters. So, definitely we will need to partition into clusters in such a way that all the points in the same cluster are similar to each other, and all the points that are in different clusters, they must be very dissimilar to each other. So, we will proceed recursively to form new clusters until the desired number of clusters are obtained. So, this is the divisive clustering. So, again here the question is, in each and every step we will need to decide which cluster we should divide further in two clusters. So, how can we decide which cluster we should choose at each step? So, we can find sum of squared errors for each and every cluster, and then we will divide that cluster into two clusters for which sum of squared error is maximum, because it means that cluster is having some points that are dissimilar to each other. So, it is better to divide that cluster in two clusters. So, and then how to split the chosen cluster into two clusters? So, we can use k-means clustering algorithm. So, recursive k-means algorithm we will use for dividing a cluster into further clusters. Now, we will see the comparison between these two different techniques of hierarchical clustering. The first one was agglomerative clustering and second was divisive clustering. So, divisive algorithm for clustering, we can say that it is more accurate. Why it is more accurate than agglomerative clustering? Because here when we are dividing the whole data set that is corresponding to one cluster in two clusters, at that time we are considering the global distribution of the data, and then we are dividing it, and then again when we are dividing one of these two clusters, so we are doing the same. So, we can say that in this case when we are at the initial steps, we are considering all data points and then we are forming clusters, while in case of agglomerative clustering we are merging two data points, and then so each and every step we are merging two clusters. So, at that time we can say that there are chances that we are ignoring other data points and we are concentrating only on those data points that we are merging, and that is why your divisive clustering algorithms results may be more accurate, or this algorithm will give you better clusters. And if we see in terms of large clusters or small clusters that we want to form, then we can say that if we will need to form less number of clusters or large clusters, in that case divisive clustering is better, because we are initially we are having a single cluster and then we are dividing it in two clusters, and then we are forming three clusters and so on. So, if we suppose we will need to find only 5 clusters, while in our data set we are having 100 data points, it is always better to do divisive clustering, because initially all these 100 data points will be in a single cluster. So, then we will divide it in 2 clusters, then one of these 2 again in 2. So, in this way in only 4-5 steps we will get 5 clusters, while in case of agglomerative clustering if there are 100 data points and we want only 5 clusters. So, we need number of steps to form 5 clusters, because initially all these 100 data points are corresponding to 100 clusters, then 2 closest data points when we will add, we will get 99 clusters, and then again 2 clusters that are closest to each other, we will merge them, then we will get 98 clusters, and in the same way we will go up to when we will get 5 clusters. So, we can say that divisive clustering algorithm is good when you need less number of clusters or you need large clusters, while agglomerative clustering is good when you need large number of clusters or very small clusters. So, in this way we can decide which particular hierarchical clustering algorithm we should use for a particular clustering problem. So, in this lecture we have seen hierarchical clustering technique, and then we have seen two important concepts, dendrogram and the second one is Shillhart coefficient. So, using dendrogram and Shillhart coefficients we can find out the optimal number of clusters, or using Shillhart coefficient we can also evaluate the results of your clustering algorithm. So, I am stopping here. In the next lecture we will see some other topics. Thank you.